Hydrogen is being hailed as the fuel of the future. But is it? So what is hydrogen? Well, for those of you that didn't pay attention at school in your chemistry class, hydrogen's the first element in the periodic table. It's highly reactive and it's the most abundant chemical in the universe. But on Earth, it doesn't occur naturally in any great quantities. It's because it's so reactive, it's mixed with other things. And one of the most common ones is water, which is H2O. Two molecules of hydrogen, one molecule of oxygen. And there's a lot of water around on this planet. Hydrogen was first identified in 1776 by a British scientist called Henry Cavendish. And he discovered that he created it by reacting zinc with hydrochloric acid. Previously to that, in 1671, Robert Boyle described the reaction between iron filings and dilute acid, which resulted in the production of a gas. The name hydrogen was given to the element by Antoine Lavoisier in 1783. The word hydro means water and gen, creator. So hydrogen creates water. So when you combust hydrogen, you get water. So in the modern day, there are a number of ways in which hydrogen is made, but only one of those is really environmentally good for the planet. There's a lot of colours have been used to describe the various hydrogen manufacturing processes. Firstly, we've got brown hydrogen, which is made with gasification of coal. Brown is bad. Then we've got grey hydrogen, made from steam methane reformation using natural gas. Grey is just as bad. Then we've got blue hydrogen, which is very similar to grey, but it uses a non-renewable energy source and it's coupled with carbon capture and storage. Yeah, carbon capture and storage has yet to be implemented to any significant degree, and it's being used to get around some of the laws and jurisdictions around the world. Blue is bad. And it's been shown at Cornell University that blue hydrogen produces more greenhouse gases than if you just burnt the fossil fuel itself. I mean, the fossil fuel industry keeps promoting this type of hydrogen, blue hydrogen, because it keeps their businesses going and they're very good at lobbying governments. So blue is definitely bad, but it's got a nice colour, hasn't it? Blue, which has been linked with electric vehicles. Yeah, clever. There is another one called turquoise hydrogen, which uses methane again and pyrolysis. Turquoise is terrible. And finally, we get to green hydrogen, which uses any renewable source, such as solar and wind power, to electrolyse water into its constituent parts, as I said earlier, hydrogen and oxygen. Green is good. But wait, there's more. There's pink hydrogen, like green hydrogen, but it's created through electrolysis of water, but it's powered through nuclear energy rather than renewables. So it's not too bad. So from a climate perspective, green hydrogen is the way to go. Unfortunately, as I've said before, some governments out there are getting blue hydrogen off the ground as it's cheaper and it sounds good. Blue EVs, yeah. Nah, forget it. And at the moment, over 90% of hydrogen produced in the world is blue. In other words, bad. Only 5 to 10% is green, which is good. Once you've made that hydrogen, there are still a lot of problems to overcome. Firstly, it needs to be stored, and it's stored in high pressure containers to liquefy it. It's quite a reactive substance, as I said earlier on. It reacts with just about everything. So over the years, those storage containers, yeah, it sort of erodes a little bit through the walls if you're not careful. So that's not very safe, is it? After some years, those tanks may need replacing. One of the better ways to store it is to combine it with nitrogen, which is in quite an abundance in our atmosphere. We've got oxygen and nitrogen, two main components in air. So combine it with nitrogen, you make ammonia. Now that's safer to transport than the gas, and it can be extracted at the point of use, say when filling up a vehicle. When it's stored in your vehicle, you've still got the problem that it's highly combustible and reactive. So once again, there are many safety concerns. Although on the statistics I've seen, it's still probably safer than internal combustion engine vehicles. They carry around a heap of petrol, which can explode and cause nasty fires. Once you've got your hydrogen to your vehicle, it can be used to move that vehicle by a couple of different ways. You can use it in a fuel cell to create electricity to turn the electric motor, or you can actually burn it directly, similar to a conventional engine. Now, the good thing about hydrogen is the only two waste products to come from it are heat and water. So, what are its advantages? Hydrogen's got some energy density about it, so you can store a lot of energy in a small space, certainly once you've compressed it and liquefied it. And when you're refueling a vehicle, it's a lot faster than charging your batteries. You just come along, plug it in, set it going, and it refuels about the same length of time as it takes to fill up a tank of petrol. So that's good. Its disadvantages are that at first it must be made from sustainable resources, and currently that's not the case, as I've already said. And manufacturing it is quite energy intensive. So at the moment, a lot of fossil fuel is burnt to make your hydrogen. The amount of energy used to make the product and then get it to where it's needed to use it, and then its use, we need to improve our technology quite a bit to affect this balance, because currently you lose about 60% of the energy to make it and use it. You lose 60% of that, you get 40% effect. Better than internal combustion engines, which are around the 18 to 20% effective, or 80% loss. But when you compare that to a battery, production of electricity put into the battery and then used, that's 80% effective, or 20% loss across the whole life of that cycle. So yeah, we need to improve our technology on hydrogen manufacture and use. At the moment, there's such a sparsity of distribution points for hydrogen in its use for, say, vehicular transport. It's severely limited. So, you know, you've got your Toyota Mirai hydrogen powered car. There's one fueling stop I know of in Perth. Yeah, what are you going to do? If you go outside of that, you're stuffed. So we need to look at ramping up distribution points before it's going to be of any use. But your battery electric vehicle, you can charge that up anywhere. We've got an amazing amount of electricity around the place. Just plug it into a socket and away you go. Then there's the cost. Hydrogen at the moment is very expensive to manufacture, and the vehicles to buy to use hydrogen are also very expensive. They're probably a little bit more expensive than the equivalent battery electric vehicle. So for passenger vehicles, it's just not on at the moment. All this needs to change before hydrogen can be considered as mainstream for your passenger vehicle. So what's the future for hydrogen? In the short term, not much. It's got a use for heavy industry, which is a very energy intensive area, but it still needs to come from green sources. It's probably got a place for heavy transport, trucks, ships, and so on. There are some hydrogen fuel cell powered planes, but not long haul. But the technology will improve. That will then make it not quite so wasteful on energy. But of course, in the meantime, what's happening with battery tech? That is going gangbusters. When you look at what's happened over the last 5 to 10 years with batteries, they've gone huge. But hydrogen, yeah, not quite so much. I'm sure at some point in time, hydrogen may well be used a little bit more commonly. We're beginning to make some green hydrogen here in Western Australia, and I believe over at the eastern states as well. But it's still in its infancy. So all this hype about hydrogen, yeah, look, let's forget it for a while. It will slowly come. But of course, in the meantime, battery tech is going to go ahead as well. It's not stagnant. Thanks very much for watching. Please like and subscribe. It does help the channel and it helps promote these ideas. Thank you.